who's going to use this video as a reference for the future, or my friend who I'm going to send it to. Let's talk about hydrocarbon of organic chemistry. If I remember correctly, it is class 12 of organic chemistry. First of all, what is hydrocarbon? It is just carbon and hydrogen bonding together to make a compound or anything. Hydrocarbon comes inside organic chemistry. Why? Because organic chemistry is a section of the science where we study all the materials or living elements which is associated or comes from the animals or any living creatures. Hydrocarbons are divided or separated based upon chain. What are those? Open chain and closed chain. What is an open chain? They are called allopathic compound. Just remember, hydrocarbons are divided into two types based upon chain: allopathic compound, aromatic compound. Allopathic compound, open chain; aromatic compound, closed chain. Allopathic and aromatic compound both have two things in common: saturated compound and unsaturated compound. Saturated compound and unsaturated compound. What does allopathic compounds look like? Simply CH3, CH2, CH3. Simple. Whereas in aromatic compound we see a closed chain. This is what a closed chain will look like. You can see they have the no end, like they just close in itself, right? Now aromatic compound simply has two types of example, which is the most basic one: cyclohexane, as well as what was the name, cyclohexane and benzene. Now allopathic compound and aromatic compound. Saturated compound are allopathic compound, alkane, which has single bond or also called sigma bonds, are a saturated compound, whereas the rest of them, even it may be double bond or triple bond, alkane, alkyne, they all are categorized into unsaturated compound. Why? Do not ask me. After that, aromatic compound also has saturated and unsaturated, but the only difference here is the chemical molecules, as well as triple bond does not exist here. I think the reason was because it requires too much energy, as well as it's not really stable, so it's not really viable, so it does not happen. Always remember, double bond or triple bond are called pi bond, just like the single bond are called those sigma bond. Now this isomerism, let's talk about isomerism. This is really one of the most interesting aspect in this hydrocarbon that I have studied. Isomerism in TLDR simply means I have the same molecular formula, but I don't function as same as you. It's like having twins, but they don't really they may look the same from the outside, but they have different interests, different opinions, different tastes, just like that. From that we come, first comes the functional isomerism. What is functional isomerism? Well, it is just in this isomerism the position of functional group is different with same molecular formula. What does it mean? Well, they have the same functional group, even the same molecular formula, but if you look closely, like use the IUPAC nomenclature, you will see that this and this has lots of difference. It really matters. There is a bigger proof here. You can count it: 1, 2, 3, 4, 5. Now the nearest one from the OH group, the functional group, is actually both 1, 2, 3, 1, 2, 3. Now, am I wrong or not? Now look at this 1, 2, 1, 2, 3, 4, 5. They also have 5, so I will use pen. Now count the OH from the nearest one. Do you count it from here or here? Tell me. Pause the video. Well, I guess you have guessed it. It will be the nearest one, that is CH3. That's why 1, 2. Sing OH, all. What is all? OH is the definition of alcohol. Chain isomerism. Well, it is in simple term, number of carbons are same, but arrangement in a different chain or become different itself. Some are like the pentene, but look at it: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pentene. Look at 1, 2, 3, 4, 5. 2-methyl butane. Look, how? That is the truth. They have the same molecular formula, but their function is different. They don't even have the same carbon in their main carbon open chain. That is how it is. Now let's look at the position isomerism. This one is a bit important, so please remember this one. In simple term, position of carbon oxygen bond is responsible for different functional groups. Let me tell you again. Position of carbon oxygen bond is responsible for different functional groups. Why is that? The examples you can just see: CH3, COO, CH2, CH3, but but it is a ketone. Why? Because the O is attached to a carbon who is just sitting here. Like ketone is just this and anything here in between. This is ketone. That's why it's but 1 2 2 on ketone. After that it is CH3, CH2, CH2, COOH. Now let me guess, what do you think? But 1L. Which L? This, look at this, the aldehyde. Why? Well, it is just how functional groups really are. And please remember that any kind of halogens do not determine the function of the carbon atoms. Look at this: CH3, CH2, CH, Cl, CH3, or CH3, CH2, CH2, CH2. Look at this. Well, the chloro is a bit different in the position, but really doesn't do anything because it's a prefix, not a suffix. 2 scolar butane, 2 chlorobutane. Look, simple as that, my baby. Damn, I think I will have to make some correction here. What is conformational isomerism? Well, this isomerism is shown compound with two or more than two compound. Methane does not show type of isomerism. Let me explain to you. Conformational isomerism is just the way to look at the carbon compounds. There are two types. First type is the sawhorse projection. In sawhorse projection, this is a little bit, I think I made a oopsie maybe. In sawhorse projection, there are two carbon atoms. There are two carbon atoms. Both of each have same amount of hydrogen. Now look, I'm using my camera as the eye. It's kind of weird. Look, if you see it from sideways, you will feel like this and this are like perfectly overlap each other. You may not even be able to see it from the sideways. This is what we call sawhorse projection, sawhorse projection eclipsed, because this is how it is. But what if it's not? What if I spin it up like we get this? No, nothing, no relativity. Well, that's kind of it. Now let's have the questions here. Which of the following does not show sawhorse projection? CH4. Why? Because for a sawhorse projection, or even for a conformational isomerism, I need two carbon atoms, whereas we don't have eligibility of anybody who does not have the study certificate to tell that it is CH4. Which of the following clauses not show conformational isomerism? Which of the following clause does not show conformational isomerism? CH2CH6, C2H5, C3H8, or none? What do you mean by it? Which of the following does not show conformational isomerism? I'm kind of sleepy. Fuck. I forgot the answer. Now in Newman's projection, it is written like this, like a sphere. This is the inside, this is the outside. Look, this is called eclipse and this is called staggered. This is what I wanted to show you. Which angle is formed by Newman's projection? 120 degree. Why? Because it is divided into three parts, and if you divide 360 by 300, they will give you around 350. I'm too sleepy. Sorry. Let me think. Oh yes, the angles. Okay, I can figure it out by using angle of rotation or angle of, no, sorry, this one. Just what could I say, just you do your stuff, like divide them by 3 because you have 3 angles to choose from. Now if they are asked about the distance between angle between this and the back one, or just the angle between the first and the second one here, they are all same, 120 degree, and are angle of rotation or angle of torsion and dehydration angle. God dang it, I'm too sleepy. Let's talk about some petroleum, kerosene, and quantum. They are made of carbon, but why they are called inorganic? Do you know why? Because inorganic is any substance from Earth, but all that living creatures are fused to create this petroleum and stuff. Why it's made of carbon, even though it is organic, it is why it's made of carbon. What bond does carbon make? A very covalent bond. Why covalent bond and why that only? I guess you have to know that we have to see the electron configuration of 6 carbon, that we can look in the electron. This is the ladder. Since it is just not perfect, he cannot blend in or even blend out properly. Let me show you the screenshot now. I don't think I have the inner strength to complete this if I tell you this one. This is my own words. Now let's go for the cyclohexane one. For cyclohexane, there are 2 forms, chair form and board form. Just remember, it is the most stable one. It has an angle between carbon and its degree is 109.5. After that, stability means how reactive. Very simple. These are both conformational are stable due to hindrance of CC atoms. Actually, I don't understand this part. I will just talk about that. This form is way more, less reactive and more stable than the previous 21. After that, we have preparation, reaction of alkane. By what? Alkyl halide. What is alkyl halide? We must see, bitch. Oh yes. When alkyl halides react with sodium, X denotes, what was it? X denotes heaven. Yeah. When alkane halides react with sodium in the presence of dry ether, then alkenes are what the hell is this tightening? For the straight upper is used, then it's called a Warzilla. For dry, did I say something out of my own dream that I was kind of dreaming while telling you? I have to watch that one. Let's talk about it. Alkyl halides can prepare alkane, but there are many kinds of reaction that I can use. But I'm going to use the most famous one, Wurtz reaction. Why? Because I need 2 carbon, aldehyde and carbon. Look at this. This X is the halogen, and the 2Na is going to snitch this 2 and make this brother again. They also need dry ether. Always and always remember, no matter what is in the product, no, it is actually important, but before that, always remember that you should have dry ether as your small experiment, because dry ether is easy to achieve, I guess, and it is as it is. Now, in the reactivity of alkyl halide, as you can see, fluorine with the smallest size is always the first one to be out. F, RCl, RB3, RI, they are all bigger than the lesser strong connection with the center. Oh yeah, the ma'am told me something like this. I wrote it in my words. In simple terms, any kind of elements that have a larger size will not really benefit from the shit, I'm getting sleepy. Where was I? Yeah, fuck. It just Fluorine, chlorine, bromine, iodine. Fluorine is the smallest one, while the iodine is the biggest one. That's why iodine disappeared the first. On the basis of size of alkyl halides. Basis of alkyl halides. What does that fucking mean? You may ask me. And it's in a simple term. CH3Cl, CH3CH3, CHCl, CH3CH3, Cl. While following words, that is 2 RHX and R plus equal X. What is this? I don't remember this one properly. On the basis of size of alkyl group. What am I really distinguishing? The size itself or the fact that it is not a good thing for a carry player? Fuck, my mind is going blank. Why am I talking about Reddit right now? I guess this is how mind really works. I think two things at the same time. Fuck this shit. On the basis of size, CH3Cl I guess is the biggest one, whereas this guy has become smaller and smaller and smaller. That's why you can see this. Now, as I told you, Wood's reaction needs sodium, the salt, as well as dry ether to even be called that. Now, let's talk about reduction of alkyl halide. Oh yeah, the reduction in Wood's this looks same, but it is reduction because oil rig. What is oil rig? Oxygen is loss of electron. Reduction is gain of electron. Right now I just got this, so I guess he is reduced. No, it is oxidized. I don't know, man. It is plus positive, but it always takes the negative. Oxygen, lone pair, not lone pair, free radical has been taken. So yeah, I can say that this guy has been, fuck, I'm getting sleepy again. Anyway, shit. Since H plus needed 1 electron, the R gave it the hydrocarbon they gave the free radical to the hydrogen. That's why it is like this, and here it is like this. It is not reduction, remember that. Reduction of alkyl halide. Fuck this shit. Simple terms, if you want to reduce it, you can reduce it by giving this halogen carbon compound mixed with H2O in the presence of copper, and we will get a oxidized and a reduced fluorine. Hydrocarbon is oxidized, whereas chlorine is there. CH3Cl plus H2O, CH4HCl. That is reduction. That is the reduction. Can you derive methane from the reaction? Two alkane groups participate as reactant. What do you mean by that? So I don't think you can actually what this one is for. Fuck, I will tell you about remember correctly, okay? What is called this electrolytic method? Well, it is just using another cathode in water and use electricity, blah blah blah. 2RCOONA, what is it? Sodium carboxylate, which is mixed with water in the presence of heat or sunlight, which is represented by HV. Now, what will happen? I had reaction mechanism which I forgot to write, and here it is. It just, the 2R is for the whole. The 2R, RR plus CO2. CO2. He used it, destroyed his double bond, I guess. CO2 plus 2Na plus NH2. What is sodium carboxylate? CH3CONA. Sodium. Where is sodium? Here. Carboxylate. No, this is actually not sodium carb. Oh, I'm very sorry. This is not. This is 2 ethanoic sodium ethanoic acid. If I remember correctly, ethanoic acid are also called acetic acid. They are mixed with water in the presence of sunlight. We get simply the same thing, ethane. Wait, please wait a minute. Mm, did I do something wrong? I'm really stupid right now. Yep, there is something definitely wrong here. Let's talk about CH3COOH, ethanoic acid, and HCH, methanoic formic acid. Now, if we have two HCOONA plus H2O and this heat CH4CO2 plus H2O, CH per methane, you can see that more the carbon gets. If I have two carbons in the reactant, I can make a methane. But if I get one carbon, I cannot make any kind of hydrocarbon compounds. Always remember electrolysis. Anode is the oxidation, while CH3 is oxidized by anode by release of 2 electrons, whereas H2 is reduced by cathode by gain of 2 electrons. H2O plus 2E plus H plus over what was this one? Oh, it's breakdown. If you break down water, it looks like this, and if I electron here and this one is already there, I get H2 gas. What is the carboxylation reaction? It is when I break down the carboxylate compound. What are carboxylate compounds? Simply COOH. COOH, anything COOH is really considered in carboxyl group. So RCOONA, Rakuda plus NaOH, which is the reduction region, mixed with soda lime or calcium oxide in heat, we get RH, Na2CO3. You know what is Na2CO3 made of? This is in class 10. Please use pause button and let me sleep for a bit. Okay, I guess you may have guessed it right now. Na2CO3 is also known as what the fuck? Washing soda. It is used for washing clothes. Now, we are going to do a real test. I'm gonna use sodium ethanoic acid plus NaOH for safety and blah 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 CH4 Na2CO3 NaOH plus CaO. I forgot why I wrote this one. After this, there is formic acid. Formic acid in part. Can formic acid participate in this? What is formic acid? Formic acid is methanoic acid, which in many instances are not allowed in the army or something. What the fuck is my brain working? HCOH plus NaOH equals to COOH, H2 Na2CO3, just the same. Oh yes, decarboxylation means breakdown of carboxyl group, where I get to have some hydrocarbons, which you can see does not exist here. Decarboxylation sodium salt of which and will be used to prepare a propane, that will be butanoic acid, just like I told you. Hydrogenation reaction. What is hydrogenation reaction? Which form interspecial compound with some spaces in the world which let me read something. Okay, so now we have reached reduction from unsaturated hydrocarbon. We will reduce unsaturated hydrocarbon. Hydrogenation reaction. Why platinum or palladium are the blocks element which form PD or PT are the block elements which form interspecial compound with some places or void in which hydrogen, boron, carbon easily trapped. So in hydrogen we use PD or PD as a catalyst. CH2 plus H2. Why H2? Because I'm gonna use the H2 here and there. PD or platinum or anything like nickel, BaSO4 or lithium aluminum hydroxide can be used for the breakdown as catalyst. So now the pi bond, this one pi bond, while the sigma bond will remain, pi bond will break, boom, I get this. Since pi 1 has been broken, we have carbon H2O plus carbon H2O. Now look, this dot represents one electron that is free. That is why we call it free radical. But you cannot call it two free radicals. That is not possible. They make a lone pair, not this free radical. Simply I just use and show here. The same goes for this one. Two pi bonds. The CH2 CH. I had to do it double twice. And CH. Also remember oh shit, I have made a mistake. I'm fucking sleepy. Here there will be more 2H2O or something. PD platinum reacts with room temperature, high temperature. Oh yes. Platinum and palladium are very viable because they react with room temperature, whereas nickel with high temperature. Physical properties. Physical properties from carbon 1 to carbon 4 is gaseous. 5 to 9 will be liquid, and 10 and beyond are in solid form. Now the best part here. What is polar compound? Well, polar compound are those in which a positive or negative compound are formed during breakdown. Well, easily example is, if I break down a compound, will it show positive ion and negative ion or not? For example, we have H2O, which I break is H plus OH minus. Therefore, water is a polarized solvent. Polarized solvent, please remember that shit. After that, we have non-polar compound. What is non-polar compound? Well, it is opposite of polar compounds. Well, let's talk about it. It is just simply free radicals are formed after breakdown. Let's take for an example of this one, CH2 plus CH2. Well, they have free radicals. Always remember, one free electron is called free radical. And let's talk about something. Where was it? Free radicals are formed during breakdown. Oh yes. What is the real difference between polar compound and non-polar compound? Polar compound is any kind of compound which, if you break down, will have positive negative signs. Whereas if you divide something like carbon, you don't have any positive negative sign, but just being in peace with their one radical. And that is what they try to tell you. Non-polar compound is exactly that. And always remember, like attracts here, not unattracts. Polar compound will only dissolve in polar solvent, whereas non-polar compound will always dissolve in non-polar substance. They cannot dissolve in each other. I guess someone will try that. Free radical example is CH3 with a free radical. Why? Because it is not CH4, so there is one electron left, so it is a free radical. Non-polar solvent, ether chloroform. It is ether chloroform, benzene, and it is nature the formula. They do not dissolve in water polar compound because they are a non-polar. Polar compound dissolve in polar solvent and vice versa. Something that I just literally told you right now. Melting point and boiling point. I'm thought boiling point at this. So simple to say, number of carbon increases, boiling point increases. Boiling point will increase as the number of carbons. Also, the boiling point will be inversely proportional to branching. Now look at the example. We have 1 carbon, 3 carbon and 4 carbon. They are also in degree. This is 1 degree, 2 degree, 3 degree, 2, 1. You get it, right? Now CH3, CH4, CH3, CH3, CH2, CH3, 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 CH3. What is it showing? Because it's like the fucking same, and I have this lesser than lesser, and I have this greater than greater. So am I making a mistake? Please look at this and think. Question what do you think I have done wrong? I guess you know the answer. Actually, you can see this is just 1 carbon, this is 3 carbon, this is 4 carbon. This section we are talking about number of carbon in boiling point, and in this one we are talking about chains and carbons. Chains, we are talking about the chain and branching. will decrease the overall area, surface area of the, the cell. Ah shit, give me a minute. So, in simple term, hydrocarbons, when they form a branch chain, they are smaller in size and kind of easy to break down, I guess. But in simple terms, their branching makes it make them way easier because their bond isn't too large and surface area is also not big. Therefore, the bigger, more branching, less the boiling point. Remember, carbon-carbon bond is also called covalent bond, whereas carbon-hydrogen bond is called van der Waals force or bond. The tendency to not dissolve in water is also called hydrophobic in nature. Therefore, hydrocarbons are hydrophobic in nature. Petroleums are known as higher chain of hydrocarbons. Remember that, my baby. They are odorless and colorless. Petroleum is a mix of hydrocarbon. Lower fraction petrol used for dry cleaning, especially for a grease. What do you mean by that? Well, petroleum has its own kind of intensity, So if petroleum is a little bit of petroleum, they're most likely used to be in a stain remover thing or like that. Substitution reaction. How the heck? What is substitution reaction? Well, it is chlorination or halogenation. They are example of substitution reaction, replacing of an hydrogen or any kind of element from the compound and taking its place instead and doing nothing but probably changing or giving some complements to the compound. Fuck. Chlorination or halogenation. Well, always remember that fluorine is too small to react. Substitute. It is too small to substitute with other type of compounds. Size matters here. Bigger the size, easy to break. Chlorine, bromine, and iodine all does that. Now. CH4 plus Cl2 is Hv. CH3Cl plus HCl. Do you see what I mean? This is just one methane plus chlorine with heat or sunlight. I get this substitution reaction. I'm really lazy, but let me try to tell you. Because of this heat, both of these got broken down. CH4 broken down into one of the two things, CH3, one free radical, whereas H plus got this plus mark and chlorine got a minus mark. Yeah. Now I'm gonna take CH3Cl and add another chlorine and Hv, use it, and CH2 Cl2 and HCl. Now you may ask, why is hydrogen getting taken out whereas chlorine does not? Simple terms, chlorine does need higher energy to be removed, whereas the hydrogen is easier to remove. So they just say, nah, give me that. CH3Cl2 Cl2 Hv CH3Cl3 HCl perform. It is just simple process. I use it to it until it's all carbon tetrachloride. By the way, CHCl3 is chloroform. Mechanism, you can see what I just told you about. Combustion reaction. I'm not gonna make too much of it because my throat is itching. Order of reactivity or substitution. Oh yeah, just CH4 is lesser than CH3. This is number of carbons. I guess we are thinking substitution reaction. I guess this is just I guess more the branching, harder to substitute. Now let's talk about combustion reaction. Combustion reaction is simply when a carbon is reacted with oxygen in presence of it produces carbon dioxide and dihydrogen oxygen. Water. It's a redox reaction. It is where a product like CO2 and H2O is produced. Exothermic reaction, enthalpy of exothermic reaction is always negative. Methane or gold gas is the best used yet. In complete combustion reaction, there is oxygen not sufficient, leaves product like carbon residue. They can be used for Black ink filter. It means fuck this, I'm out. It's not complete.